Search algorithms in AI are a fundamental technique for problem solving. They're used to find solutions to complex problems by systematically exploring possible solutions. Essentially, search algorithms in AI work by examining possible solutions and determining if they meet certain criteria. If a solution is found that meets the criteria, it's returned as the answer. In this video, we'll discuss the different types of search algorithms and their applications. Before we discuss this in detail, please subscribe to our channel and press the bell icon. Breadth First Search. Breadth First Search is one of the simplest search algorithms in AI. It explores all possible paths from the start state to the goal state in a systematic manner. The algorithm starts at the initial state and explores all of the neighbor nodes before moving on to the next level of nodes. This process continues until the goal state is found. BFS is a complete algorithm, meaning that it will always find a solution if one exists. However, BFS can be very memory intensive as it needs to keep track of all of the explored nodes in memory. It's a simple but powerful search algorithm used in artificial intelligence that explores all possible paths from the start state to the goal state in a systematic manner. It begins by examining all nodes adjacent to the starting node before moving on to the next level of nodes, and it continues this process until it reaches the goal state. One of the advantages of BFS is that it's a complete algorithm, meaning that it will always find a solution if one exists. This makes it an ideal choice for solving problems where finding a solution is more important than finding the optimal solution. However, BFS can be very memory intensive as it needs to keep track of all the explored nodes in memory. Another advantage of BFS is that it can be easily implemented using a queue data structure, which makes it an efficient algorithm for finding the shortest path between two nodes in a graph. This property of BFS makes it a popular choice for finding the shortest path in applications such as GPS navigation systems and online maps. However, BFS can also have limitations, particularly when dealing with large graphs or when the search space is very complex. In such cases, BFS may require an enormous amount of memory and processing power to explore all possible paths. This can make it impractical or even impossible to use BFS for certain types of problems. Depth First Search. Depth First Search is a popular search algorithm that is used in a variety of applications, including artificial intelligence. In AI, DFS is used to search for a solution in a problem space, such as finding a path from a starting state to a goal state. DFS operates by exploring a path as far as possible before backtracking to explore other paths. This approach can be useful in AI applications where the goal state is located deep in the problem space, as DFS can quickly reach the goal without exploring all possible paths. One common AI application of DFS is in game playing, where the algorithm can be used to search for the optimal move in a game tray. DFS can also be used in natural language processing, where it can be used to search for relevant information in a large corpus of text. However, DFS has some limitations. It can get stuck in infinite loops if the search space contains cycles, and it may not always find the optimal solution if there are multiple solutions. To overcome these limitations, variations of DFS, such as iterative deepening, can be used. Uniform Cost Search. Uniform Cost Search is a more sophisticated search algorithm in AI. It works by exploring the nodes with the lowest cost first. The cost of each node is determined by the sum of the costs of the edges leading to that node. UCS is guaranteed to find the optimal solution, but it can be slow if there are many paths to explore. A-star search. Do you know what the A-star algorithm is? It's a common search method because of its ability to locate the shortest route between two sites. Nonetheless, it has the potential to squander time by revisiting previously investigated branches. This may cause the procedure to take longer and be less effective. The A-star graph technique, however, can help with this predicament. This rule, implemented in the version of the algorithm, eliminates the re-exploration of already investigated branches, which might speed up the search process and save time. When the forward cost of two consecutive nodes is less than or equal to their backward cost, the A-star graph algorithm has found an optimal solution. The consistency property guarantees that the algorithm will always select the optimal solution. Hence, the A-star graph algorithm may be the answer you're seeking for if you're in need of a dependable and effective search method. Greedy Best First Search. If you're looking for a faster alternative to the popular A-star search algorithm in AI, then you might want to consider the greedy best first search. This heuristic search algorithm works by using a heuristic function to estimate the cost of each node and only considering the estimated cost to the goal state instead of the total cost. However, keep in mind that while greedy best first search may be faster than A-star search, it's not guaranteed to find the optimal solution. Simply put, greedy best first search is a heuristic search algorithm that is commonly used in AI. It estimates the cost of each node by using a heuristic function and considers only the estimated cost to the goal state, rather than the total cost. Although this algorithm is faster than A-star search, it's not always guaranteed to find the optimal solution. So, if you're interested in using greedy best first search, keep in mind that it has its limitations. Hill climbing search. Hill climbing search is a local search algorithm in AI. It starts at an initial state and explores neighboring states by making small changes to the current state. The algorithm selects the neighbor that is closest to the goal state and repeats the process until the goal state is found. Hill climbing search is often used for optimization problems, but it can get stuck in local maxima and may not find the global optimum. Simulated annealing search. Simulating annealing search is a global search algorithm in AI that is similar to hill climbing search. However, it has a probability of accepting worse solutions in order to avoid getting stuck in local maxima. Simulating annealing search is often used for optimization problems, but it can be slow as it needs to explore a large search space. Genetic algorithms. Genetic algorithms, a type of search algorithm in the field of artificial intelligence, mimic the natural selection process of genetics. These algorithms generate a population of random solutions, and then select the best ones to reproduce and create a new generation of solutions. This cycle repeats until a solution that meets the criteria is found, making them highly effective for solving optimization problems. Although genetic algorithms can be slow, due to the need to generate and evaluate a large number of solutions, they're widely used in various fields of AI. Whether you're trying to optimize complex industrial processes or design the perfect machine learning model, genetic algorithms offer a powerful tool for finding the best solution to your problem. In particular, the United States Department of Defense has recognized the strategic importance of artificial intelligence and has recommended the use of genetic algorithms to improve their decision-making process. With their ability to quickly find optimal solutions, genetic algorithms can help the military make more effective decisions and stay ahead of their adversaries in the technology race. Constraint satisfaction search. Constraint satisfaction search is a type of search algorithm in AI that is used for problems with constraints. It works by generating a set of possible solutions and then checking if they meet the constraints. If a solution does not meet the constraints, it's discarded, and the process repeats with a new solution. Constraint satisfaction search is often used in planning problems, scheduling problems, and other problems with complex constraints. Applications of search algorithms. Vehicle routing. Vehicle routing problems are a class of optimization problems that seek to determine the optimal series of route for vehicles to deliver goods or services to customers. These problems involve minimizing the cost and time taken to reach the destination, and they're typically solved using heuristic algorithms, such as search algorithms. Researchers have shown that machine learning algorithms, such as reinforcement learning, can also be used to solve vehicle routing problems. Additionally, there are various real-life vehicle routing problems, with features beyond the classical problems of the literature. For instance, some problems take into account the heterogeneous character of the fleet, capacity constraints for vehicles, and time windows for deliveries. Nurse scheduling problem. The healthcare system requires the provision of 24-hour healthcare services, which necessitates the full-time presence of nurses. However, since nurses can't work continuously without rest, scheduling is necessary to ensure that shifts are allocated efficiently to enhance productivity. In order to solve the problem of nurse scheduling, search algorithms are applied. Retrieving records from databases. To retrieve information or records from databases, search algorithms are used. In this process, the desired record is considered the desired state, and the algorithm searches through the search space by making goal tests until the desired record is found. Industrial processes. Industrial processes can benefit greatly from the use of optimization algorithms. In the case of chemical reactions, for example, these algorithms can be used to optimize parameters such as temperature and pressure in order to achieve a desired outcome. By defining the initial and desired states, the optimization algorithm can perform a series of actions until the desired state is attained. This approach can enhance the efficiency of industrial processes and lead to better outcomes. That's all for today. Which search algorithm do you think is the best and why? We would love to hear your thoughts in the comment section below. I hope you liked the video, and if you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing videos from us. Thanks for watching.